Good morning, good afternoon, and good evening, depending on where you are. Thank you for joining us today for our webinar on demystifying NIR techniques. We have a packed agenda for you, so I'm just going to jump into it, and then I look forward to having a good discussion with you at the end. So to start off, this webinar is part of a series of knowledge sharing sessions that we have facilitated for our Feed and Farage customers. I'm hoping that some of you have joined us for our earlier webinars as well. This is the last in our series of 3 webinars that we have organized. The first one was about flexible quality control. The second was about best practices around NIR calibration models. And now we will talk about NIR techniques with a focus on feed. This will all culminate with the Advanced NIR Forum, which is a physical event where some of the largest NIR users in Feed and Farage in the world will be joining us physically at our FossCalibrator Innovation Center in Hiller, Denmark. This is also we also organize many regional advanced NIR forums focused on the challenges that we have in the different regions, and also regional webinars for a larger audience who cannot travel physically to some of the forums that we organize. At FossCalibrator, it's very important for us that you not only just use our instruments, but you're able to and solutions, but also are able to utilize it to the maximum. So we focus on solutions or challenges that are for the industry, by organizing these webinars and areas where a lot of things can be shared. So I have 3 simple guidelines for today. We have planned a session where we'll speak for around 30 to 35 minutes, giving you an introduction to the topic. Then we will have 10 to 15 minutes for questionnaire. So you can already start asking questions in the interface that you have, and I'll type in a while to ensure that you know where it is. And then we will pick it up at the end. And finally, I want to say that it's great seeing all the response that we've seen for the webinar so far. We've had a lot of signups, and I can already see a lot of you have joined, which is great. But we also asked you, what are your expectations from this webinar? And what we've seen is that we have a wide range of people who are generally curious to advanced gurus. We've tried to put together an agenda that matches all of your needs, but we are, of course, juggling different needs. So I hope that you find it relevant. And when you have more advanced or other questions, please just write to us so that we can respond to them. So today we have 3 people from our side. We have Jakob, who is our Vice President for R&D technology. And he will take you through a lot of the technical aspects of some of the choices we've made. We also have Magnus, who's the Program Director for R&D for our Grain and Feed business unit. And he'll look forward to answering some of the questions that you guys have together with us. And finally, there's me. I'm the Business Unit Director for Grain and Feed. And while that means different things, what I'm most interested in is that we are actually solving the right problems for you, our grain and feed customers, particularly feed customers, because today we're going to be talking about feed now, but also in the future. So that's the 3 of us who will be talking and speaking to you today. And thanks again for joining us. The agenda for today has been split into 2 parts. We will talk a bit about megatrends in feed and forage and how we see NIR's role. I won't go too deep into this because a lot of you would have joined us for our earlier webinars and we've gone deeper into this. We've essentially will talk to the same things, but then connect it into a customer-driven approach to the technology selection. So the choices we've made in our instruments and in our solutions, which will also give you an overview of what's the NIR techniques, but also explain to you the choices we've made from a feed point of view. If you're interested in going deeper into the megatrends, of course, you're free to go and check out the old webinars. Those recordings are available on our website. So you will know that at FossCalibrator, we look at all the things that are happening in the feed value chain through the lenses of 5 megatrends. We have raw material variability and least cost formulation, feed safety and animal health, consolidation that's happening, a lot of labor challenges, and of course, sustainability is hotter and hotter as a topic as every year goes by, and especially the extreme climate events that we are seeing these days. What that leads to are some serious challenges. I will not go too deep into it. Like I said, you can check out our earlier webinars if you want to do that. But when you think of those challenges, they translate into very specific needs from an analytical solution. And we've put down 4 needs that we see as the most critical ones. One is that you want to have good control over the raw materials that are coming into your value chain in a VUCA world. A VUCA as in volatile, uncertain, complex, and ambiguous. That is what the world is today, but it's also becoming more and more tomorrow. So you definitely need more control over your raw material as the years pass by. Once you have these raw materials entering your value chain, you definitely want fast and reliable analysis methods so that you can actually play around with the recipes for meeting your product quality goals or to meet cost goals that you might have. And finally, you want to ensure that you have control over your final product quality and you are delivering what you have promised to your customers. Food safety, of course, is a part of this. I've grayed it out because we don't believe that NIR is the right solution for that, but we of course have solutions for that, and we will not touch upon it. But we'll be happy to take you through that at a different point if you reach out to us about this. Looking at the top 3 ones, it's very clear that NIR provides a solution to these challenges. Everything from raw material control to analysis for recipe changes, and finally final product quality. But when you think about NIR systems, there are different kinds of NIR systems out there. And if you look at our FoSS portfolio across our different industries that we choose to operate in, you will see that we are using most NIR techniques across our portfolio. So be it diffraction grading NIR or FTIR or diode array, or when you look at it from how the sample is presented, transmission NIR versus reflectance NIR, we are using most kinds of NIR techniques that are there across our portfolio. But we have made certain choices in terms of what technology to use for specific applications. So that is the question. How do you decide which NIR technique is best for the feed industry? And this is where, while of course we are the experts in technology at what we do not have the technology and then use that as a hammer to find nails to solve. We are actually looking at, in the customer segments that we have chosen to focus on, be it grain, be it feed, be it dairy, we look at what is the critical needs of our customers there, what are the conditions in which the NIR has to operate, and what does it have to achieve, and then use that for technology selection. So a customer driven approach to technology selection as we look at it. So what is important for an NIR system for the feed industry? Now, there are a lot of table stakes, like you need the level of accuracy that your reference methods have, and you need repeatability so that there's traceability and all of that. But beyond those table stakes, which are fundamental in any choice that you make, there are 4 key considerations that we believe are important for the agri, particularly the feed industry. You can see them here. There's something around the kind of samples that you have to analyze and the sample presentation that is associated with it. There's something about transferability and the ability to build models that are transferable across a large set of devices. There's something about the robustness of the solution at hand, or the instrument at hand, and the solution overall as well. And some questions around or some considerations around the relevant range that you have to cover to answer the questions and add value in a feed setup. Let's go into it one by one. So if you want to take full advantage of NIR in feed, these are the 3 key challenges, as we talked about, that you need to solve. But that requires handling very different kind of sample times with a relatively simple presentation. You are not always sitting in a lab and you want to have relatively simple sample presentation and get good enough results that fit the purpose that you're going for. So when it comes to raw materials, it could be grainy, the different grains that you use. It could also be powders like fish meal, or it could be bone meal, etc. It could also be amino acids, vitamins, etc., which are much more finer powders. So there are different kinds of samples just in the raw material. There's a lot of variability there. When you're thinking about analyzing different elements in the for flexible recipe changes within your production or within your value chain, it could be ground samples, it could be mashes, it could be slurries. All kinds of things are possible depending on where in your production or where in your value chain you measure. And of course, when it comes to final product, it could be pellets, it could be kibbles if you're thinking about pet food. It could also be meat in oil, meat in liquid kind of situation, or chunks in liquid kind of measurements that you have to do. So when you think about samples from a feed, which also includes pet and all of that, you are looking at a wide range of sample types, from grainy to powder to slurry to pellets. These are all important for you to measure in a good way. So that's the first consideration that is there. Moving on, if you look at the feed industry and the structure that the feed industry has, it is a very complicated industry. I don't have to tell you this. You're operating in the industry, in the value chain every day. But you also know that there are large players who need high levels of transferability across their devices. So it could be large feed companies on one side who are, who have deployed multiple, if not hundreds of NIR instruments across their different production sites. Or it could be solution providers like Nutreco. I've picked up a few comments from some of the articles that you can find on our website, which talks about the network of NIR instruments that Nutreco, for example, has, but also other solution providers have in this. What is important in this context is that you are able to centrally manage and centrally have single calibrations even that work across these fleet of instruments with high levels of transferability. So this is again an important consideration when we come to feed, because of the industry structure that is there and the need to provide this value for the value chain. Another consideration is the robustness of the parameters, or the robustness of the instrument itself from an agri and feed value chain. Let's compare and contrast these two images on the left and the right. Imagine you're trying to build an instrument that has to work across pharma labs and agri value chain. Pharma provides a completely different environment. You're sitting in an environment where things are very controlled, there are no dust, everything is pretty much under control, but at the same time there are many other considerations around the regulatory compliance and the accuracy, different levels of different things. On the other hand, when you're sitting in a feed environment, you are potentially sitting in areas where while you will still be in a lab, you might be extremely close to high levels of vibration. Or if you are thinking about process instruments, now I don't have that in the image, but if you're thinking about process instruments, you might be sitting in an extremely dusty environment, and of course vibration will be a challenge as well, and it has to be relatively compact as well, because you're not sitting with a lot of space both in your lab but also in your process. So the consideration around robustness is extremely important and very different from a feed and agri point of view. Then finally, I think we also need to think a lot about what is the relevant range of the spectrum for feed. And we believe that in a feed and agri context, everything from the visual range up to 2500 nanometers is extremely important. Starting on the visual range, there is plenty of studies that show that pets, pet food quality, etc., is judged a lot on color and how it reflects light and texture and all of that. And similarly, there are a lot of studies also from an aqua feed point of view where color is an important parameter in terms of feeding habits and feed conversion ratios, etc. We also have similar studies in poultry and bovine and other feed as well, but the economics are sometimes a bit different, so you don't focus that much on it, and there are other parameters that you want to optimize. But color is important in that context, so the visual range is extremely important, which is from 400 to 750, etc. On the other hand, of course, you have a a lot of parameters that you want to measure, be it moisture, fat, protein, ash, fiber, amino acids. I mean, amino acid is not a parameter, but of course, these are the things that you want to measure, and that requires that you have a visual, a range going up to 2500 nanometer. So these are some of the important considerations to recap it, especially when you put on the industry hat. Sample presentation, we need a solution that is suited across powder, pellets, slurries, grains, etc. We need a technology that can enable high levels of transferability across the different devices that you have in your fleet. We need a solution that is relatively resistant, or not relatively, sorry, that is resistant to vibration. And we need a technology that works well with good levels of signal to noise ratio and good accuracy across the 400 to 2500 nanometer range. So these were the considerations when you put on the industry or the customer hat, so to speak, in terms of making technology choices. Now I will hand it over to Jakob, who will talk to you a little bit about the technology and how they translate, how choices in technology are impacted and translate back into these needs. Over to you, Jacob.
Thank you. Can you see my screen?
Yes.
Yes. Okay. So thank you, Sabri. I'm Jacob Falkenberg. I'm Vice President for the Technology Department R&D, and I'd like to go a little bit more into detail about the topics that Sabri mentioned and demystify what is actually behind this. So very often when it comes to NIR, the question is which kind of instrument should I choose? Which kind of spectrometer technology should I choose? But I think it's the right way, the right place to start is actually what kind of sample do I need to measure, and how do I optimize the performance of that measurement? And this is why I started with the topic about sample presentation. There are different ways of presenting the sample to the instrument, or you can say different illumination geometries, and they have each the relevance for a different kind of samples. So if we look a bit into that, the two most well-known illumination geometries or sample presentations are transmission and reflectance. And in transmission, the light source is placed on one side of the sample, and the detector is on the other side of the sample. This is a sample presentation that is usually applied in the shortwave near range from 850 nanometers to 1100. And one of the big advantages that with this kind of sample presentation or illumination geometry, you're able to measure a large volume in a short time, typically cubic centimeters per second, which means that it's a good choice for heterogeneous or inhomogeneous samples where you want to generate a reliable mean of the sample. And also it's a good choice for samples with high water content, because you're able to penetrate deep in this wavelength range where water does not absorb so well. The typical parameters here are fat, protein, and moisture. Now, in reflectance, the signals are collected on the same side as the illumination, so it's a reflectance from the surface of the sample. It's useful in the full spectral range that Sabri mentioned, but it should be noted that you typically only measure the surface layer, so not very deep into the sample. On the other hand, with reflectance, you would typically have access to more parameters than in transmission, typically also starch, fibers, sugars, and other stuff. And because of the limited volume of the sample, this is best suited for rather homogeneous samples. There are some variants of transmission and reflectance that are worth mentioning. One is so-called lateral transmission, where the signal is collected on the same side as the illumination, but the detected light is offset from the illumination spot. This means that lateral transmission is a variant of transmission, you can say, and it's well suited for applications where you want to access the sample from one side, typically in a pipeline in a process environment. Finally, there's the transflectance geometry, which is, you can say, a variant of reflectance. In this case, you put a reflecting surface on top of the sample in order to enhance the back reflected light to the detector. And this is well suited for semi-transparent samples, for instance, slurries and some olive samples as well. In transflectance, the advantage is that the light path is well defined. It also allows access to the full range that Sabri mentioned, from 400 nanometers to 2500 nanometers. So summing this up, you can make sort of a decision tree kind of thing, where depending on the type of sample, whether it's heterogeneous or homogeneous, and the nature of the sample, whether it's grains, powders, more bulky stuff, or certain kind of dairy products, and then from this you would have a sort of a guideline, at least, to which kind of sample presentation or illumination geometry to choose for a specific application. It's worth mentioning that in this forum that there are some overlaps between the infotecs that are used for many crop analysis and the DS3, because with the accessories to the DS3 you can actually measure many of the same kind of samples that you can in transmission with the infotech family. So this was a short overview of sample presentation or illumination geometries. Then going to the next step that Sabri mentioned, transferability and standardization it is. And this is the art of going from one unique NIR instrument to hundreds of identical instruments. I would try to explain in some detail how this actually works and what kind of performance you can get from this with certain examples. So basically, standardization are the group of methods that we use to ensure that a population of instruments all will generate the same results on the same sample. And standardization is what ensures the transferability of the models, that you can actually build a model on one or few instruments and then transfer them to other instruments and use them right away. Standardization is a two-step process. In the Foss factory, we make sure that when the instruments leave the factory, they are standardized or made identical using what we call a master concept. And when the instruments get to the customer side, there are internal or external calibration targets that are used periodically to make sure that the instruments also stay standardized after the lift production. One of the key points in standardization is to standardize the x-axis, the wavelength axis of the instrument. And here's an example of how well this can be done on a DS3, where we have followed the peak over 25 months, and you can see that the peak is really stable and with very little very little variation on the wavelength axis. And this variation is well below what is needed in order to make sure that it doesn't have any effect on the prediction models that may be applied. Combining the x-axis or wavelength axis standardization with an intensity standardization, you can make fully standardized instruments. And this is shown here, where you can see 10 spectra that are almost identical, and then after applying the standardization methods, you can see that the spectra in the bottom becomes very identical. But the right way to evaluate this is actually what is the impact on the model. And this is an example of this. In this case, one fat model on a feed application was built on one DS3, and then it was deployed on 5 other DS3s. And then the results are compared in this graph, where you can see how well the 5 additional DS3s reproduce the results of the DS3 where the model was developed, and it looks very nice and equal on this line, of course. If we zoom in and look a bit more into the actual numbers, with this kind of model, you will typically get an accuracy. Sorry. Do you see my screen? Yeah. You would typically get an accuracy of 0.7%. If you repack the sample, you would typically get, in this case, a deviation between repeated measurements of 0.14%, which represents sort of the homogeneity of the sample. And then if you look at the pooled standard error of difference between the instruments on the model side, that's basically the transferability. It's only 0.07%, which means that the very, very small contribution from the transferability does not have any impact on the model accuracy in the end. And this is what transferability means in practice, that you can actually build a model on one or a few instruments and deploy them on a number of instruments and use them right away. Finally, I would say a few words about NIR spectrometer technologies, and this is really where the points about robustness and spectral range comes into play. There are a number of different NIR spectrometer technologies, but the two that are most commonly used are the monochromator technology and the FT-NIR or Fourier transform technology. So the difference is that with the diffraction grating or monochromator technology, the light source, the source from the light is projected onto a grating, and by turning the grating, you choose or pick the wavelength one at a time that you want to measure. And you can generate a full spectrum of your sample by turning the grating and get access to the wavelength you want. In the Fourier transform technology, the light goes through what is called a Michelson interferometer, and what you get out in the end is an interferogram. And when you apply a Fourier transform, you get back to the spectrum. In the end, you end up with a NIR spectrum from both technologies, but there are some differences that I will get back to on another slide. Then there's a third technology that is worth mentioning, and that's the DDA technology, which is basically a variant of the monochromator technology. It's also the light being projected onto a grating, and the grating will then disperse the wavelengths into different spatial areas. But instead of turning the grating, there's a detector array that picks up each of the wavelengths. The advantage of this kind of spectrometer technology is that that there are no moving parts, so it's ideal for an environment where you have heavy vibrations, for instance, a process environment. Typically, the DDAs come in two variants depending on the detector technology. So you would have either the shortwave NIR range from 850 to 1050, or the long wave NIR range from 1100 to 1650. For NIR instruments, FoSS have chosen to use the monochromators and the DDAs. And the reason for that is that monochromators are ideal for food and feed analysis in NIR and easy to use for the customers. One thing is that in the monochromators, the optical resolution is constant across the wavelength spectrum for feed and foodstuff, which matches the absorbance spectrum of the samples very well. So it means that you don't need to worry about setting the optimal performance that comes with the monochromators that we deliver. It's also possible with the monochromators to generate a high signal-to-noise ratio in the full spectral range both in the visible but also in the shortwave NIR from 850 to 1050. And with the monochromators, depending on design of the grading, you can access the full range from the visible range to 2500, which is what we want for many of the feed applications. The DDAs are limited in the spectral range compared to the monochromators, but they share otherwise the same benefits. And the reason why, or when we use the DDAs, it's typically in process environments where you don't want moving parts in the system if you want to attach the spectrometer directly to a vibrating pipe. And then again, the size and the weight of the DDAs also make them ideal for portable instruments like the DA 1650 or the meat scans. So, in conclusion, in order to achieve the transferability, we use efficient methods of standardization to make sure that a population of instruments will generate the same results on the same samples. To cover the broad spectral range from the visible up to the 2500 nanometers, we use monochromator-based instruments like the DS3. By choosing the, looking at the type of the sample, we have a number of different illumination geometries possible, which in the case of powder, pellets, and slurries are well covered by the DS3. And in order to meet the needs of a robust solution that is resistant for vibrations, we can apply the DDAs in a process environment, but the monochromator is also a very robust instrument in the in a lab environment. So, thank you.
Perfect. Thanks a lot, Jacob. We have got a few questions, so I think in the interest of time, we will just start going through them one by one now that we have the opportunity. And of course, if there are more questions coming in, please just type and we will pick them up. So I'll go through them one by one. Though this actually came quite early in the presentation, so I guess that this was something that the audience member had already thought of coming into this. So the question is, can NIR be used to test final product purity? What is the limitation of NIR? For example, if the purity should be 99.99%.
I think it's difficult to make a short one-sentence answer to that, but I mean, it will depend on the impurities. I mean, what does the absorbance spectrum of the impurities look like? If they're very strong, we can detect small concentrations, but probably this sounds like per million, and that would typically be out of range with NIR. I think that's a short question, but if there are some details on the application, I think we can look into that and come with a more specific answer.
I think we'll follow up because I think so. Sue, who has asked this, Mr. Sue, please reach out if you have additional questions, or just type it in and we can pick it up. Or if it's a special case, we can of course go deeper into it. So the next question, you mentioned color as being important for feed. Would you recommend DS3 or DS3F for feed applications? Maybe that's something that I can pick up and quickly answer, right? So like we said, there are many studies show that color is important in a feed context. It's definitely controlled a lot in aqua feed and pet feed for sure. In certain other feed as well, it is covered, but then it's also what do you optimize and what are the economics, etc. So we provide DS3 and DS3F primarily driven by the economics and what we see as the most important parameters to optimize. So it is very much driven by what you want to do. We of course recommend the DS3F for the feed, which does not cover color, as the question asker knows. But if you have the need to color, to maintain color, or to control color, then you have the DS3, which you can use for that as well. Yep. Then I'll move on to the next one. Okay, there are a lot of questions coming in, so okay. What I have observed is that there is I assume, so I'm adding a few words here, but what I've observed is that fine tuning of device whenever is deployed is required. So when you're talking about transferability, is it directly predicting the same in all, or fine tuning / offset calculation is required? So do you need to offset and fine tune for each device, is what I think the member is asking.
Again, I think it's difficult to give a general answer to that, because it depends a lot on the model, and it depends a lot on the accuracy you want to achieve, and how well it goes with the reference analysis. Of course, you can choose models that uses ranges of the spectrum where there's not really a lot of information, and that might give you something that does not look like transferability. And of course, you can also have very strict requirements that the transferability cannot fulfill. But in general, yes, you can take the model from one instrument to another and use it directly, and this is done by customers that have larger fleets of DSs. But there can be variations among the models and the applications.
I think then I'll pick up a question that has come. It's a bit later, but I think it's relevant. How many instruments should I include for building a calibration? Again, I know there are no simple answers, but yeah, the spectrum of how many instruments.
I would rather not put a number on that, but I would very much. I mean, if there's a specific, setup with a certain number of instruments, I think we could go into a specific discussion about this. What's the best approach?
I think that pretty much reflects our customer focus, right? So we definitely recommend reaching out to your local FoSS representative, because it's not a add 10 instruments kind of answer, right? It is very dependent on what you're testing, how you're testing, how you're set up, and all of that, and the variability that you see in your this thing and all of that. So in your raw materials or in the samples that you're testing, etc. So we highly recommend getting in touch with the local FoSS representative for this discussion. Cool. I have something here which is related to how do you deal with the aging of light source, for example, in process applications and measurements in transmission. Is that clear?
Yeah, in process application for the Profoss, there are actually 2 lamps installed in the instrument, which means that if one lamp stops working, then it will switch to the other lamp, and then you have time to change the lamp, so you can keep running and have a high uptime. I mean, in transmission, of course, or any other lab instrument, if the lamp blows, then you need to exchange it. I mean, if you want to have some preventance towards this, then it would be of value to run with a fixed number of hours for the lamp, and then exchange, so you can be sure it's always running. But otherwise, if the lamp fails, then exactly due to these internal reference targets that are in the instruments, it will compensate for the variance or the change in the lamp spectrum.
Makes a lot of sense. And again, we do. Sorry, Magnus. Yes, please, Magnus.
I can just add to this. It's extremely important that the cooling of the lamp works in the right way, because the we have seen that the cooling has a huge effect on the lifetime. So if the instrument is standing up against the wall and the cooling fins can't work, or the DS3 is lacking cooling liquid, for instance, then the aging will go a lot faster.
No, that's a very important point, Magnus. And I also want to say here that we do have preventive maintenance contracts and solutions from FoSS that, you know, if you do subscribe to those, then we ensure that on a periodic basis, our people are coming and making sure that you know, there are no challenges and these things are operating as they should as well. So that's something that we offer as well. Okay, we go on to the next one. Whether grinding of feed or ingredient sample before NIR scanning is important to get accurate results, or the NIR is calibrated for unground samples as well. So basically, is grinding of samples a requirement to get accurate results?
I mean, you can develop models both for grinded and ungrinded samples. I think for feed stuff, it depends on the homogeneity of the ungrinded samples, but I would think that it would be an advantage to dry and grind the samples to generate a better or more representative mean of the composition in the sample.
Yeah, makes a lot of sense. It depends on what you have calibrated for, I guess.
Yeah, I mean, what one can do is if you have a model on the ungrinded sample, you can try to repack it, measure it again, and look at what is sort of the repack deviations, and that will give an indication of how homogeneous the sample is.
Makes sense. Cool. Again, a long question, so I'll have to read it and then understand. So in feed, raw materials play a major role in finished product, and according to the season, raw material can change, but the final composition will be the same: protein, fat, ash wise. So is a new model required, or can the same model work? So, you know, what essentially is saying is that as the seasons change, the raw material composition might be the same, but it still changes. So do we need to build new models, or can the old models
I think
work?
it's generally it's good practice when you build models to use samples that are collected over the season or even more seasons. The global models we have for the Infotech for different crops have been collected over several years, over many seasons, and it does improve on the accuracy. So it is recommended to have seasonal variation covered in the samples when you build the models yourself.
Yeah. And in case you are interested, I can see that we are still getting a lot of questions on the calibration models. I would highly recommend that you go and you know, watch the earlier webinar that we had, which talked a lot about how do you maintain and validate, and you know, what is the process and who should do it, etc. So the earlier webinar that we had last month, which actually talked much deeper into this subject and gave some guidelines around how to test and what should be a good way to maintain your calibrations as well, be it seasons, be it you know, over years as well. Okay, so I don't know, this is a question, but Peter here asks, it means you cannot install an NIR directly in the feed process. Example, after cooler directly in the main batch mixer. I didn't completely understand it, but I'm assuming that we are talking about process instruments here, and I can try to take an answer. So when it comes to process NIR, you can install it actually across the whole production process that you have. You can do it at the start, just after the silo, if you want to have control over your raw materials that are going into your process. It's a bit like having a lot of virtual silos, right? Because today you might have 2 or 3 silos and then you're putting everything in. But if you have something there, then you can control and know, you know, as the different parts of the silo come in, you know, what are the parameters that are going into your feed. You can also do it at different places, like after the cooler or after the mixer, etc. Of course, you have to calibrate for that and make sure that you know what you're measuring. And then if you have the opportunity to control it, then you need to be able to control it and all of that. But it is definitely possible with the right calibration models and validating it. And of course, you can also do it at the end if what you want is much better control over the finished good. I mean, with a benchtop instrument, the number of samples that you can take are limited. With a process instrument, you can do it actually much more often, so you have much better control over your final product quality. There are a few more questions, but I've around edible oils, etc. So we can't touch upon all the questions, unfortunately, but we will make sure that we get back to you via mail, or the local FOSS representative will get in touch with you to answer your queries. I'll end with one last question, which I think is a good way to end. The question is, because I had a meeting, I was late for this webinar. Can I watch the recording? Definitely. All of you who have signed will get a link to the webinar where you should be able to watch the recording either today or tomorrow. We have the same webinar later today as well for the other time zones. And once we have that also done, we will be sending out the links that you will get. But once again, thank you so much for joining, and thank you so much for all the questions and the it's great to see that you're so curious and you have a lot of questions. Please reach out if you have further questions. We are only happy to help you here, and I recommend again going back to some of our older webinars. But thanks again, and have a great rest of the day. See you. Thanks, Jakob.
Thank you.
Thanks, Magnus, for joining in. See you.
Thank you.